Hello everyone! Welcome back to the physics class. Today we will proceed the chapter Force and Motion, and I will highlight the concept of impulse and impulsive force. In this concept, there are two learning outcomes. So, at the end of this video, you must able to communicate to explain impulse and impulsive force. Second, you must be able to solve problems involving impulse and impulsive force. What is impulse? Okay, impulse known as the product of force and time of impact. We can write it as Ft. Impulse also defined as the change of momentum. Wait, did you still remember what the momentum is? Let's recap. Momentum is P. It is defined as the product of mass and velocity. This is the formula of momentum. P is equal to mv, where m is mass and v is velocity. Now let's get back here. When I talk about change of momentum, the symbol is delta P. And in constant mass, delta P is equal to m delta v. Delta v also can be write as v minus u. So, impulse is equal to mv minus mu. Therefore, we also can write impulse as Ft equal to mv minus mu. And the unit for impulse is Newton second or kilogram meter per second. Look at the example of impulse. A tennis ball hitting the concrete wall and bounce back. From the information given, we know the tennis ball with mass 0.05 kg has initial velocity 50 meter per second, and the final velocity when it bounced back is negative 45 meter per second. The negative sign here means the tennis ball moving in left direction. So, to calculate impulse of the tennis ball is using the formula mv minus mu. When we put the value into the formula, we will get impulse of the tennis ball is negative 4.75 kg meter per second. And impulse is vector quantity. So, the negative sign here means the impulse was in the left direction. Now, what about impulsive force? Impulsive force is defined as the rate change of momentum. When we talk about rate, it must divided by t. So, F is equal to mv minus u divided by t. Or we also can write as F equal to impulse divided by t. And the unit for impulsive force is Newton. Or we also can use the unit kilogram meter per second squared. Look at the example of impulsive force. Same situation just now. Impulse that we have calculated just now is negative 4.75 Newton second. If the tennis ball takes 10 seconds to bounce, so the impulsive force is impulse divided by t. We put the value into the formula, we will get the impulsive force is equal to negative 0.475 Newton. And impulsive force is the vector quantity. So, the negative sign here means the force was in the left direction. For your information, impulsive force obeys Newton's third law. This law states that for every action, there is an equal but opposite reaction, meaning that the tennis ball also receives the same force when it hitting the wall. Now, let's move on to the effect of increasing or decreasing time of impact. First, what will happen when we increasing time of impact? Okay, this is the situation. The girl and the mattress. A girl is jumped on thick mattress of gymnasium. During landing, the time taken is longer because of the mattress. Thus, the magnitude of impulsive force will reduce. Look at the formula of impulsive force. When the time taken is longer, so the impulsive force will reduce. Next, what will happen when we decreasing time of impact? Okay, this is the situation. The pestle and the mortar. The pestle and mortar are made of hard materials. During pounding, pestle move very fast, while mortar stop the motion of pestle in a short time. Thus, a strong impulsive force is produced, and chili can be broken into pieces easily. Look at the formula of impulsive force. When the time is short, so the impulsive force is strong. Now, we can conclude that the impulsive force, which is F, is inversely proportional to T, which is time of impact. Next, let's moving to situation involving impulsive force in the safety features of vehicles. Look at this vehicle. There are 5 safety features was designed. First, headrest. It was designed to prevent injury of head which move back when car suddenly accelerates forward. Second, windscreen. It was designed to protect the driver from wind and temperature extreme. Third, crumple zone. It was designed to compress during accident. It also lengthened the time of impact and reduced impulsive force. Fourth, airbag. It was designed to prevent driver from hitting the steering wheel, dashboard or windscreen. Last but not least, seatbelt. It was designed to prevent driver from being thrown forward. Now, let's try your understanding. Ready? Question 1. A nail of 0.02 kg mass is driven into a wooden block. Its initial speed is 30 meters per second and is brought to rest in 5 seconds. Find the impulse. Okay, the formula of impulse is the change of momentum, which is mv minus mu. So how to know which is v? Look at the question. When I said that is brought to rest, means the final velocity is 0 meter per second. So when we put the value into the formula, we will get the impulse is negative 0.6 kilogram meter per second. Next, how to find the impulsive force? By using the formula of impulse divided by T, we put the value into the formula, which is T is 5 seconds, and then we will get the impulsive force is negative 0.12 Newton. Question 2. The crumple zone in front of the car is important for safety because it could reduce, is it A, the time of impact, B, the impulsive force, C, the damage of the engine, or D, the kinetic energy of the car? Crumple zone was designed to lengthen the time of impact, means it will reduce the impulsive force. So the answer here B, because the crumple zone will reduce the impulsive force. So far, that's all for today. Thanks for watching. See you again.